Hello everyone, welcome to the YouTube channel of YourPedia and Engineering Career Point. So I am Vinay Sharma, your mentor of mechanical engineering here. So as you know, the Oil India has announced the vacancy for various posts, okay, including the senior officer as well as the fire safety engineer here. And there for the mechanical engineer there are around 35 vacancies for the senior officers, and for that I am going to provide you here the previous year paper solutions which has been held on the 2022. So 2024 exam has already been solved by the Rajiv sir here. Okay, now the next paper is the 2022 which I am going to solve it right now. Okay, now and if we talk about the paper pattern, I have already told you many times the paper is consisting of 100 questions here. Out of the 100 questions there are 40 questions of the non-technical part and the remaining 60 questions are from the technical part here. Okay, and the 60 questions are very simple. The few numericals are going to be there, otherwise the theory is very simple. Only few numericals are going to be there and the numerical levels are very easy here. Okay, only one liners numerical is there. Okay, so you are going to see it now. Now let us start with the questions here. So in this case the first question which we have is during the acceleration of a particle along a circular path, the centripetal acceleration depends upon. So now just see, whenever we talk about the body which is rotating in a circular path here, there are two types of acceleration here. The first one is known as the radial acceleration and the second one is known as the tangential acceleration. Okay, coming back to the radial acceleration, it is also known as the centripetal acceleration here. And if you just see the magnitude of the centripetal acceleration, it is defined as, it is given by v square upon r, or you can simply calculate it with the product of angular velocity square multiplied by radius here. Okay, now so if you just see from the formula, you can see in this case the centripetal acceleration is depending upon the instantaneous velocity of the object, that as well as it is also depending upon the radius of curvature of its path here. Okay, so option number C will be the correct answer here. So that is a very simple question. Now the next question, the two equal and opposite parallel forces whose line of actions are different forms again a very simple question is there. So here we have one force P and here we have another force P here, and in between them we have some gap. Okay, now whenever the two equal and opposite forces are acting and they are having some gap here, okay, they are having some eccentricity between their line of action, then it forms a couple, and the magnitude of this couple is given by P into E, where E is representing the distance between the line of action of two forces. Okay, along with that, if you just see, if this couple is parallel to the area of cross section, then we say that it is a twisting couple, and when this moment or a couple is perpendicular to the area of cross section, then it is known as a bending moment here. Okay, so that is a very simple definition. Now coming back to the next question, the smallest circle that can be drawn from the center of the cam and tangent to the pitch curve is called as. Now just see, in the cam terminology we have different type of circles. We have a base circle, we have prime circle, we have pitch circle, we have a pitch curve here, trace point. A number of terms are there. Okay, and what is the meaning of pitch curve here? So basically this is our cam profile, let us say. Now what we have done in the case of a roller follower, first of all I have just located the trace point. So let us say the trace point is located at the center. Now if I just fix the cam and rotate the follower all around the cam profile here, you will find the curve which is known as the pitch curve. So this is the pitch curve here. Okay, now in this case what you can see, the cam is rotating, let us say about point A, and this pitch curve and the cam profile is having a different radius. So now I am taking a smallest radius here and I am creating a circle by taking a smallest radius which is basically connecting with the pitch curve here. So I can say this circle is known as the prime circle. So this is a prime circle here actually. Okay, so in this case option number B is the correct one here. In the same way, if you are drawing a circle close to the base, close to the cam profile, this circle is known as the base circle here. Okay, so this is the simple definition here. So I can say this is a prime circle where the circle is tangent to the pitch curve. So that is a very simple case. Next part, a medium velocity gears have the velocity in between. Okay, so now just see, whenever you classify the gears, the classification of the gear is also being done on the basis of the speed here. Okay, for example, if the value of the speed is less than 3, then we say it is a low speed gear. Okay, low velocity gear. When the speed is lying between 3 to 15, when it is lying between 3 to 15, then we say it is a medium velocity gear, and if the speed is more than 15, then we say it is a high velocity gear. Okay, so in this case the option number B is going to be the correct one here. So that is the correct answer. Coming back to the next question. The primary unbalanced force is maximum when the angle of inclination of the crank with the line of stroke will be. Okay, now what is the formula of the primary unbalanced force? So primary unbalanced force is given by mr omega square. So first of all, just talking about the unbalanced forces here. The total unbalancing force is written as mr omega square cos of theta plus cos 2 theta by n here, where if you just see, if you further simplify it, you are going to see that we have first term mr omega square cos of theta, then we have another term mr omega square cos of 2 theta upon n here. Okay, now in this case the first term is known as the primary unbalanced force. So this is the primary unbalanced force, this is the secondary unbalanced force here. So now you can see the value of the primary forces are going to be maximum when the angle of theta is equal to 0 degree or either 180 degree, okay, or either 360 degree. So at this angle the value of the primary unbalanced force is going to be maximum, and all the other remaining this value is going to have some different values. Corresponding to 90 degree we are having a zero unbalanced forces here, okay, and so on. So I can say the option number C is going to be the correct one, because at this angle only we are having a maximum primary unbalanced forces here. Next part. When the rotor rotates in a clockwise direction when viewed from the bow and the ship is steering to the right, then effect of the reactive gyroscopic couple will be. Now just see what is the meaning of here actually. In this case, just if you just see, first of all, what is the bow here? Bow is representing the front portion of the I can say ship, and the stern is representing the rear portion of the ship here. Okay, so let us say it is representing the bow here. Okay, now how the rotor is rotating? Rotor is rotating in the clockwise direction. So now you can see if the thumb is having the orientation like this one here, okay, I can show the direction of the angular velocity like in this way. If I am seeing it from the front, from the bow end, and it is rotating in the clockwise direction. Okay, now correspondingly I have to define the coordinate axis also. So here we have x-axis, here we have y-axis, and here we have z-axis. Now what is given to us? The ship is steering to the right. Now the ship is steering to the right, so here you can see the ship is steering to the right. So that simply means in that case the axis of the angular velocity will change like this one here. Okay, so this will be the case here. So here you can see it is changing like this one. So I can say the corresponding effect is going to be this one here. Okay, so in this case you are going to see this effect is going to be there. It is about the z-axis only. Okay, just try to understand it here, because this question is from the gyroscopic part and it required a very complete visualization here. So first of all, you are seeing the rotor in the clockwise, you are seeing the rotor rotating in a clockwise direction, which I can show like this one here. Now the rotor is rotating to the right portion here. Okay, oh, just give me a second. So this is a wrong one here, because the right one is this one here, na? So basically the rotor is there and it is rotating to the right. So if it is rotating to the right, so you can see the angular velocity is going to be like this one here. Okay, so in this case it is going like this one. So here you can see the active gyroscopic couple will be like this one. Now if the active gyroscopic couple is like this one, then the reactive will be like this one here, and this action is taking place due to the it is taking place about the z-axis here. Okay, so the final effect you are going to observe that it is raising the bow here and it is lowering the stern here. So option number A will be the correct one here. So that will be a simple case. Okay, I am repeating once again here. So here you can see, let us suppose this is the axis here, axis of the spin. The rotor is rotating in the clockwise direction, and how you are taking the turn? You are taking the turn in toward the right here. So if you just see it from the front, you are going to see you are moving in this direction here. So I can simply say it is going to be rotate like this one here. Okay, so here you can see this is representing the active gyroscopic couple about the z-axis. Okay, it is trying to lower the bow here and raising the stern. So the reactive gyroscopic couple will be like this one here. That means it is lowering the stern and it is raising the bow here. Okay, so correspondingly the option number A is going to be the correct one. So you have to remember that X is representing the axis of spin here, Y is representing the axis of the precision here, Z is representing the axis of the gyroscopic couple there. So option number A will be the correct answer in this case. Now coming back to the next question. During the static loading, stress concentration is going to be more serious in the ductile material, brittle material, ductile and brittle material here. So that's again a very simple question. In this case, what happens here? Stress concentration does not create a serious problem in the case of ductile material. Why so? Because in the case of ductile material, the cracks may get elongated here. So due to which the stress get redistributed here. But in the case of brittle material, we don't have a redistribution of stresses there. So that is why generally in the case of brittle material, the stress concentration creates a create a very serious problem here. So option number B will be the correct answer in this case. Next part, which of the following are suitable for the screw jack? That is a simple question here. So generally the square threads are generally used in the case of screw jack here. So option number D will be the correct one here. Next part, the material of rivet. The material of the rivet, that is also a very simple case. It should have a high toughness and it should have a high ductility here. So again option number D is the correct one here. So now you can see we have done almost 10 questions here, and there is no numerical questions are there, and the theoretical questions are very simple. In a closed coil helical spring, shear stress factor is given by. So shear stress factor is having a direct formula, okay, in the case of closed coil helical spring, which is given by 2c plus 1 upon 2c, which can further be written as 1 plus 1 upon 2c here. Okay, so option number A will be the correct answer in this case. Now the next part is, if the diameter of the bearing is 10 millimeter and the diameter of the journal is 5 millimeter, then what will be the diametrical clearance ratio? So this is the first numerical in this exam here. So here if you just see, we want to find out the diametrical clearance ratio. Now what is the meaning of that? It is simply defined as the simple diametrical clearance divided by diameter of the journal here. So if you just see, in this case the diameter of the journal is 5 millimeter, diameter of the bearing is 10 millimeter here. Okay, so first of all we have to find out the diametrical clearance. So diametrical clearance will be diameter of bearing minus diameter of journal divided by diameter of journal here. So diametrical clearance ratio will be 10 minus 5 divided by 5. The answer will come out to be as 1 here. So option number B will be the correct answer. So that is again a very simple case. That formula is there. Next, find the natural frequency of the system shown in figure. Stiffness K1, K2 and K3 is given to us, and also the mass is given to us. Okay, there is no option because in the paper there is no options mentioned there. Okay, so you can raise the objections also. So here in this case, if you just see the diagram very carefully, K1 and K2 are adjusted in the parallel, and the whole configuration is in the again a parallel configuration here. So if you just see, in this case I can simply write, okay, so understand that whenever the springs are arranged in parallel, in that case the equivalent stiffness can be calculated just by taking a simple sum here. Okay, so I can write the K equivalent is going to be equal to K1 plus K2. Okay, we can write in this way. Just give me a second. Yes, it can be written as in this way: F is equal to F1 plus F2, and we have a same. Yes, so in this case you can see we can just put all the values here. So you are going to find that the K equivalent will come out to be as 5000 Newton per meter. Okay, this is the equivalent stiffness of these two springs. Now what we have done, we have replaced these two springs with a single spring. Now again, if you just see very carefully, these two springs are again in parallel connection. Why? Because if you just displace this spring mass by some distance, the two springs are going to be displaced by a same deflection here. So I can say again these two springs will be parallel to each other. So therefore I can write the K equivalent, the total stiffness, equivalent stiffness of the spring can be written as K equivalent plus K3 here, and the final value will come out to be as 5000 plus 1500. So answer will come out to be as 6500 only. Therefore I can write the natural frequency of the system will be equivalent to k dash upon m, and the final answer will be 650 divided by 10 here. Okay, just take the under root and you will get your final answer. Okay, so you have to mark the correct option according to that. Okay, so again the question is very simple, you just have to use the basic principles only. Next question, if in the vibratory system the amount of external excitation is known, that means the external forces which you are applying over the system is known to you, then it is known as, it causes the damped vibration, undamped vibration, random vibration, deterministic vibration. First of all, that will become a case of a forced vibration. Okay, nothing is given regarding the damper and undamper, so that it may have a case of forced damped vibration, it may have a case of forced undamped vibration here. Okay, and if the frequency with which you are applying the force to the system is known to you, then you can simply find out the vibrations also, natural frequency also. So that will be a case of deterministic vibrations here. Okay, so option number C will be the correct answer. Next question, when a body is slightly displaced from its position of rest, a body is said to be in stable equilibrium if, okay, now just see, whenever we cover up the equilibrium, there are three types of equilibrium. The first one is a stable, then we have a neutral, and then we have a unstable. In the case of a stable equilibrium, if you are disturbing this system, then what will happen, the system will try to bring the system will return to its original configuration here. Okay, it is the same case like the body is oscillating in the curved surface here, and similarly if you are displacing the body and the body is not coming back to its new position, but it is making a new position as it is stable position or a equilibrium position here, then we say it is a neutral equilibrium. And the third case, whenever we are displacing the body and the body is not coming into the state of equilibrium here, no matter where it is wherever it goes here, so it will be a case of unstable equilibrium there. So in this case I can say a body is said to be in stable equilibrium if it return back to its original position here. So option number A will be the correct answer. Next question, the slope of the curve is given by the Closest-Clapeyron equation on PT, HT, VT and ST plot here. So that is a very simple case, because in the case of Closest-Clapeyron we simply find out the value of dP by dt. Okay, and it is a slope of a pressure and temperature curve here, where we define three different type of curves here. Okay, the fusion curve is there, we have a vaporization curve is there, we have a sublimation curve is there. Okay, so option number A will be the correct answer in this case. Next part, a circular rod of diameter 60 millimeter and 600 millimeter long is subjected to a tensile force. The modulus of elasticity is given to us, and the we have to find out the approximate elongation here. So that is a very simple case here. You just have to use the direct formula, that is delta L is equal to PL upon A here. Okay, now you know how much load you have applied, you already know the length also, you already know the area also, and you already know the E also. So just put all the values into this expression and get your final answer. Length is 600 millimeter, area is pi by 4, 16 square, E is 200 into 10 to the power 3. Okay, so if you solve it, you are going to get the answer as 0.149 something here. Okay, so option number B will be the correct answer. As far as if I just find out this value, that the delta L will come out to be 0.15 millimeter there. Okay, so that is a very simple case. Now coming back to the next part here, 1 megapascal is equal to, that is a simple case, 1 megapascal is equal to 10 to the power 6 Newton per meter square. It can also be written as 1 Newton per millimeter square. Okay, so in this case option number B will be the correct answer. Next part, a cylindrical pipe of diameter 2 meter and thickness 2 centimeter is subjected to an internal fluid pressure of 2.5. What will be the circumferential stress here? So whenever you are doing this question of this type here, just see that whether it is a case of a cylinder or a sphere here. So in the case of a cylinder, we know that hoop stress or the circumferential stress is given by PD upon 2T here. Okay, so P is given to us 2.5, diameter is given to us, that is 2 millimeter, 2 meter here, and thickness is 2 centimeter, that is 20 millimeter here. And if you just find out the exact value, you will get your final answer there. Okay, just find out this, and the answer will come out to be around how much answer you are getting. I think the option number A is going to be the correct answer here. Okay, option number A will be the correct answer here. Okay, just find out this value. Next, the radius of the Mohr circle is equal to. So basically this is a wrong question here. Okay, because the options won't be matched here. So if we have to find out the radius of the Mohr circle, what is here, sigma 1 and sigma 2 is known to us. So here you can see, if I just create a Mohr circle, here we have 150, here we have 50, and this will be our circle here. Okay, so this will be the radius. So I can say the radius will be simply sigma 1 minus sigma 2 by 2. Okay, because sigma 1 minus sigma 2 is representing the diameter here, and if you just take the half, you are going to get the radius. So corresponding answer is coming out to be 50 megapascal here. Now in this case, if you just see, scale is given to us that 1 centimeter is equal to 10 megapascal. So I can write the 50 megapascal is going to be equivalent to 5 centimeter. So I think there is some unit mistake here. Okay, so I think the unit is going to be millimeter here. So correspondingly, the option number A will be the correct answer. Okay. Next question. The section modulus of a triangular section of base width 12 centimeter and height 18 centimeter will be. Okay, see, we have to find out the section modulus. Okay, now what is the section modulus? Section modulus is moment of inertia by r here. Okay, so correspondingly in this case, we are having a simple formula, that is bh square by 24 of the triangle. So if you just put all the values into this expression, that is 12 into 18 square 24, you will find the section modulus here. Okay, and the answer is coming out to be around 162 here. So option number B will be the correct answer. Next, for a long slender column of uniform cross section, find the ratio of the critical buckling load for the case of one end fixed and one end hinge to the case of both end hinge. So when the one end is fixed and one end is hinge here, in that case the buckling load is given by 2 pi square EI upon L square. That is the first formula. And when both the ends are hinge, at that point of time the formula is pi square EI upon L square here. So if you just take simply the ratio of these two, you are going to see the value will come out to be 2 here. Option number A will be the correct answer. Okay. Next part, in this case, the atomic packing factor for the HCP crystal structure is, that is again a direct formula here. So we have a 0.74 value for the HCP crystal, for the FCC crystals here. Okay, for the BCC we are having the 0.68, and for the simple cubic we are having the 0.52 here. Okay. Next question. The property of a material by virtue of which it undergoes changes in the size with time under the action of constant load is known as the creep here. Okay, that is a simple definition of a creep. In that case, what is happening? The body is there is a property by which it is undergoing a deformation with respect to the time, even though the load is constant here. Okay, so it is also known as the time dependent motion, the time dependent deformation. Next part, in an iron carbon diagram during the eutectic reaction, the liquid cools to. Okay, so now just see in this case what is the correct answer. So basically the eutectic reaction is a reaction in which the liquid is getting converted into the two different solids here. The first one is the austenite and the second one is a cementite here. So option number C will be the correct answer here. Okay, na? So that is again a very simple case. Next, crystal structure of gold. What is the crystal structure of gold? That is again a very simple case. In this case, the FCC, the gold is having a FCC structure which is having a atomic packing factor of 0.74. Okay, so just do one thing, just remember the names of some few metals. Okay, for all of these structures here, just see which type of material is having a BCC, SCC, SCP and FCC here. That is important for you. Next part. Which of the following heat treatment is used to produce fine bainite structure in the steel. That is a very simple case. Again, this is a stamping process is here. Okay, so option number C is the correct one here in this case. Next, ability of a sand grain to stick together. That is also a very simple case. That is known as the cohesiveness. Option number B will be the correct one here. Next, the term flash is commonly used in the case of investment casting, centrifugal casting, sludge casting, or die casting. So here in this case we are having the answer as die casting. Okay, this type of question doesn't need any explanation here. These are the one-liner questions. Okay, from the production you are not going to see any numerical, just a simple theory is there. So for covering the production part, practice as much as possible MCQs here, then it will be sufficient for you. Next part, swaying is similar to the dash in the action against the work. That is again a very simple case. It is a radial forging here, in which what you are doing, you are applying the forces on the heated metal in the radial direction. Okay, that is a swaying operation. Next, an operation of cutting any shape from the sheet metal without using special tool. That is a case of that is a definition of nibbling here. Okay, so option number D will be the correct answer here. Next, in powder metallurgical process, infiltration technique improves the. So due to the infiltration of external, I can say the liquid or an oil here into the material, the density, strength as well as the toughness all going to be get increased here. So option number D will be the correct answer. Next, in a single point cutting tool, the angle between these side cuts, angle between the straight cutting edge on the side of tool and the side of shank is going to be known as. So that is again a simple definition of a side cutting edge angle here. Okay, the basic definitions of all the angles, I can say, or the nomenclature is very very important from the metal cutting here. Okay, now next part, in a machining operation that approximate the orthogonal cutting, the chip thickness before cut is 1.5 millimeter. Chip thickness after the cut is 2.5 millimeter. What we have to find out? Chip thickness ratio. So chip thickness ratio, R is defined as T upon TC, where T is representing the thickness before uncut, that is 1.5. TC is representing the thickness after the cut, that is 2.5. So corresponding R is going to be 0.6 here. Okay, option number B will be the correct answer. So here you can see that this exam is not going to take too much time here. If you have practiced the sufficient amount of questions here, that will be sufficient for you. Okay, the one-liners are going to be there. Within 5 or 10 seconds you can simply solve the question. Which of the following is the manufacturing method for the cemented carbide tool here? So out of this method, for the cemented carbide tool, we prefer the powder metallurgy process here. Okay, so in this case answer is going to be powder metallurgy here. Okay, next part, during the ultrasonic machining, tool vibrates at. Okay, just understand in this case the tool is vibrating. So first of all, the tool is vibrating, it is having a very low amplitude. Okay, small amplitude is going to be there, but the frequency is going to be very very high. Then only it can cut the material, it can remove the material here. So I can say it is having a low amplitude and the high frequency is there. Okay, so option number B is the correct answer there in this case. Next, the operation of enlarging the end of a hole cylindrically is known as the. Okay, so in this case, but again you can see the simple definition is there. Okay, so I can say the option number C is the correct answer, that is it is a counter boring operation. Next, in a limit system, the following limits are specified for a hole and for the shaft assembly. Dimensions of holes are given, dimension of shafts are given. We have to find out the tolerance. What is the meaning of tolerance? The difference between the upper limit and the lower limit of the hole. So it is given to you 0.05. Okay, coming back to the maximum material limit of the hole here. So the maximum material limit, it is going to take place when the hole is going to be present at the lower limit here. Okay, so the corresponding lower limit condition of the hole is known as the maximum material limit. So here you can see the hole is having a lower limit as 20 here. Okay, so that will be the option number B. Just remember that minimum material limit is going to be the upper limit of the hole, maximum material limit is going to be the lower limit of the hole here. Okay, that is the important case. Next, in a hole and shaft pair designation of 40H7D9, the number 7 and 9, these are very simple. 7 and 9s are representing the tolerance grade here. Okay, IT7, IT9, these type of things here. So option number D is going to be the correct answer here in this case. Next, grade 1 slip gauge is used for the tool room application, calibration grade, workshop grade. Okay, so now just see, we have a different type of slip gauges here, which is having a different grades like grade 00, grade 0, grade 1, grade 2, etc. Okay, all of these different types of grade are having these specific functions here. Some are using for the precision work, so some are using for the rough work here. For example, in the similar case, if we are having the grade 1 slip gauge, it is used for the tool room applications here. Okay, so just remember that this is some high level questions is there from the metrological part, which is generally not covered by the students here. Okay, now so you have to remember this condition. Coming back to the next question, which of the following can extend the range of an angle block set to 360 degree? In this case, the true square is basically used to extend the range here. Okay, so option number B is the correct one. Which of the following is used as a comparator? So basically the comparator is used to compare the size of any standard material or a standard body with the reference body here. Okay, so we have different type of comparators, like we have an electrical comparator, pneumatic comparator, okay, or I can say hydraulic comparator is there. So in this case, the dial indicator out of all of these four is a comparator here. Okay, it is a mechanical comparator basically. Next, surface irregularities primarily arises due to the feed mark of the cutting tool, that is a correct one. Vibration caused during the manufacturing operation, that is also a correct one here. Okay, so I can say option number C, both are going to be the correct answer here. Okay, next part, which of the following is concerned with the selection of path or route which the raw material should follow to get transferred into the finished product? Okay, so now just see here, out of this, process planning is basically concerned with the selection of path. Process planning is not a single thing here, it comprises of many stages here. So first stage is the routing, then we have a scheduling, okay, then we have a dispatching, and then we have a expediting here. So if we talk about the routing is basically concerned with the defining the path or the route, with which path or route has to be followed by a material here. Okay, scheduling is basically done to make ensure that when the material has to cross the route here, when it has to follow the route or when it has to follow the path here, that is concerned with the scheduling. If we talk about the dispatching is basically concerned with the actual movement of the, I can say, the material through the route here. Okay, and if we talk about the expediting here, expediting is simply representing the inspection. Okay, that you are tracking that where the material has reached here, okay, or does it have encountered any problem here, that is a part of expediting here. So all of these things come under the category of process planning here. So option number C will be the correct answer. Next part, stoke is a unit of, that is a very simple case, it is a unit of kinematic viscosity here. Next, for a completely submerged body with a center of gravity G and center of buoyancy B, condition of neutral equilibrium, that is again a very simple case. When the center of gravity and the center of buoyancy are coinciding with each other, we say it is a case of a neutral equilibrium. Okay, so here option number A will be the correct answer. Next, which of the following is the correct assumption made in the derivation of Bernoulli's equation? Non-zero viscosity, that is a wrong one here. Steady flow, that is a correct one. Compressible flow, rotational flow. Option number B is the correct one here. Next, according to Nigoratse experiment, boundary is called the smooth boundary if the ratio of K by delta. So here if we define the ratio of K by delta, where K is representing the average roughness, delta dash is representing the thickness of laminar sublayer. On the basis of these two ratios, we are defined that whether the boundary is a smooth or a rough boundary here. Okay, so in this case, if the value is lying between less than 0.25, we say it is a smooth boundary. If it is lying from 0.25 to 6, we say it is a transition boundary, and if it is greater than 6, we say it is a rough boundary here. Okay, so option number B will be the correct answer. Next, the system in which matter and energy both can flow in or out of the system, that is a simple case, open system is there. Which of the following relation is correct for a reversible adiabatic process? Okay, so relations are not given to us, we cannot mark the answers here. So this is the second question which came wrong in the exam. Next, on pressure temperature diagram, the point representing the coexistence of liquid and solid. So in the case of PT diagram, we have the curve like this one. Okay, so this is a PT diagram for all those substances other than water, specifically other than water here, okay, which basically contract during the I can say freezing here. Okay, all the substances which contract during the freezing is having a graph of PT graph like this one here, and all the substances which expand during the freezing, like for example like water, the graph is going to be like this one here. Now in this case, if you just see, we have solid, here we have liquid, here we have vapor. Now liquid and solid we are talking about this graph we are talking about. So this is known as the fusion curve here. Option number B will be the correct answer. Okay, now fusion curve is going to be like this one here in this PT diagram for the water. Next, a system at 500 Kelvin receives 65 kilojoule per minute from a source at 1000 Kelvin. The temperature of the atmosphere is given to us. What we have to find out? We have to find out the net change of entropy. So basically the heat is transferring from 1000 Kelvin source to 500 Kelvin source. Okay, in that case we have to find out the change in entropy. So here I can say it can be find out by using this expression here. Okay, so if you just solve it, you are going to find the delta S is coming out to be around, maybe it is coming out to be around 6.5, I think. How much value you are getting here? 1000 minus 500 by 500. Yeah, you are getting 6.5 here. Okay, so option number A will be the correct answer there. And the entropy change is going to be positive because it is a irreversible process here. Okay, so that is again a very simple case. Now coming back to the next question. Internal energy of an ideal gas is a function of, that is a simple case, it is a function of temperature only. Next, in an open cycle gas turbine power plant, adoption of the intercooling increases the thermal efficiency, decreases the thermal efficiency, decreases the net work output, none of these. So basically intercooling is generally done to reduce the work input to the compressor. So if you are reducing the negative work into the cycle, the corresponding net work is going to be increased. Okay, so I can say the net work output is going to be increased here, but we cannot comment directly on the intercooling here. We cannot directly comment on the thermal efficiency here because the mean temperature of heat rejection is going to be reduced, that is okay, but the mean temperature of heat addition is also getting reduced here. Okay, just understand that. If you just see, if you want to write down the formula of the efficiency in terms of mean temperature of heat addition, I can rewrite the formula like this one. Now due to the intercooling, mean temperature of heat addition is decreasing here, as well as the mean temperature of heat rejection. It may increase, it may decrease, or it may have any effect here. Okay, so just remember that case. In that case, we are not sure about that whether what is the effect on the mean temperatures here. The one thing is damn sure that we know that the mean temperature of heat addition is going to be reduced by significant here. Why? Because compressor work is continuously decreasing and the input to the boiler is at a lower temperature now. And the mean temperature of heat rejection, we don't know that whether the mean temperature of heat rejection is decreasing or it is remaining constant or it is increasing here. Okay, it depends upon the actual condition. In I can say in the actual conditions here, or most of the time, the mean temperature of heat rejection is almost same here. Okay, there is a little bit significant change in the mean temperature of heat rejection. So if I just neglect that change and if I just consider the mean temperature of heat addition is decreasing, so corresponding negative term will increase and the efficiency will reduce here. Okay, that is why whenever we are carrying out the intercooling reheating, we are also we don't do, or I can say we cannot carry out it individually here. Okay, we have to club the intercooling and the reheating with the regeneration part also. So in this case, option number B will be the correct answer. Next question. The efficiency of an Otto cycle is 75% and gamma is equal to 1.5. Find the compression ratio. So here we know that efficiency is given to us 0.75. R is given to us, sorry, R we have to find out. Okay, so now you can see 1 minus 0.75 is equal to 1 upon R to the power 0.5 here, and R will be equal to 4 square. The answer will come out to be as 16 here. Okay, so that will be a case. Next, Refrigeration is generally produced by melting of a solid, sublimation of a solid, evaporation of a liquid, all of these here. Okay, so now just see what is the meaning of refrigeration. Refrigeration is a process of maintaining the low temperature here. Okay, so if you just see, if the melting of the solid is taking place, that means the solid is absorbing the heat here. Okay, similarly in the case of sublimation of liquid, solid is directly converting from solid to vapor here. It is absorbing the heat, that is why it is converting into the vapor here. And similarly in the case of liquid, the evaporation of the liquid from liquid state to the vapor is going to be taken place when you supply the heat into the system. So as you are supplying heat into the system, the corresponding heat from the surrounding is going to be reduced. So I can say all of these three are going to create a refrigeration effect. Okay, so option number D will be the correct answer. Next, if unsaturated air is passed through a spray of continuously recirculated water, the specific humidity will increase while the dry bulb temperature decreases. Okay, this process is called as, first of all, dry bulb is decreasing, that means it is a case of cooling here. Okay, correspondingly unsaturated air is passed through a spray of continuously recirculated water here. So I can say the water content is going to be increased here. So we can say it is a case of a cooling and humidification. Okay, so in this case out, if you just see, the evaporative cooling can be marked as a correct answer here, because it consists of sensible cooling as well as the humidification case here. Okay, so option number B will be the correct answer. Next, specific speed is of a turbine, it refers to the speed of a machine of a unit dimension, is a number which predicts the performance of a turbine. It depends only upon the head under which the machine operates here, is independent of the speed of actual turbine here. So basically this is it is a number which predicts the performance of a turbine here. It is not a dimensionless number here. We have two different formulas for specific speed, and it is used to compare the different types of turbines which are operating under the same head. Okay, same operating conditions. So if the operating conditions are not changing, and then you can simply compare the Kaplan turbine with the Francis turbine, Francis with the Pelton turbine, etc. and so on. Okay, so option number B will be the correct answer. Next, in a turbine, the ratio of the runner power to the water is known as the, that is a simple case, that is known as the hydraulic efficiency there. Next, why are surge tank used in the pipeline here? Because to relieve the pressure due to the water hammer. Okay, that is the main purpose of using the surge tank here. Next, the main characteristic curves are obtained by maintaining the constant basically head here. Okay, so here you can see total 60 questions has been solved, and it has not taken so much time here because the questions are very simple. Only the basic theoretical questions are there. If you have a basic understanding of each and every topic, then you can simply solve the problems here. Okay, few 1 or 2 questions are out of topic here, like we have a questions from metrology part. Okay, because generally those topics the student don't cover up here. So make ensure that whenever you are preparing for this particular exam, focus on the metrological section very well. Okay, that is an important question. That is an important part for you. Okay, so I hope it is very clear to all of you. So that's it for this particular video. Now we will meet in the next video with another paper here. So thank you very much.